fraction. All right, shouting out at you from West Virginia. Welcome. I hope you're ready to go. Okay, I know you're waiting on with bated breath for joke of the day because it is the best part of the day. So let's do this thing. So give me a rock group with 4 men who don't sing. A rock group with 4 men who don't sing. Mount Rushmore. So if you're unfamiliar, way out in the West, in South Dakota, in America, in the United States, there is a rock formation, as you can see, with 4 men carved out of it, but they do not sing. So there's your rock group with 4 men that don't sing. So let's rock our way into fractions. We're going to take a look at first at what a fraction is and how to convert between mixed numbers and improper fractions, and then vice versa with improper fractions to mixed numbers. So let's take a look at first at just the idea of what a fraction is. So a fraction is a ratio. Sometimes we call them fractions, sometimes we call them ratios. But the bottom line is that whether you call it a ratio or a fraction, it is a comparison of 2 numbers by division. So when you're comparing the 2 numbers, you'll see it look like this, and typically not typically, but you always have this little bar here. So you'll have one number up here on the top, which we call the numerator, and one number down on the bottom, which we call the denominator. So we've got numerator here, and we've got denominator here. And that combination, that comparison, gives us what we call a fraction, or in other words, a ratio. Now, when those quantities are the same, when their units are the same, let's say, for instance, that we are comparing the number of girls in a group to the number of girls in a group, whatever that comparison would be, you have the same units as girls and girls. Well, let's say, for instance, we've got a fruit bowl. And then that fruit bowl, we're comparing the number of oranges to the number of oranges. So in other words, when those units are the same, you have a ratio. However, when the units are different, the ratio suddenly becomes what we call a rate. Let's go with that fruit bowl idea. So let's say within our fruit bowl, we have apples and oranges within the fruit bowl. Well, if we're comparing the apples to the oranges, now we have different units. So that's going to be a rate. Or let's say, for instance, within that classroom, we have girls and we have boys. Different units. So now that ratio is going to be a rate. Now there's a very common rate that you're used to dealing with. When you're driving down the highway, you check your speed. That speed is a rate. Now here in America, we clock our speed with miles per hour. Miles per hour. And that word per indicates division. So when we hear miles per hour, we need to think of it this way, as miles divided by hour. And so that gives us this concept of this fraction, or like I said, a rate, because our units are different on the numerator and the denominator. This is a unit of length or distance. This is a unit of time. So they're different units, therefore we've got our rate, miles per hour. If you're international, oftentimes you don't do miles per hour, you'll do kilometers per hour. But it's the same concept of a unit of distance compared to a unit of time. So this is what a fraction is, a ratio, a comparison. And oftentimes we'll designate that comparison as a part out of a whole. So in other words, with that fruit bowl concept, when I'm talking about the number of apples out of the fruit bowl, that is a part of the whole. How many apples are in the whole fruit bowl? Now notice I've underlined the words out of. That is because whenever you hear the word of in math, not out of, but of, you should be thinking multiplication. Of indicates multiplication in math. But the word out of does not indicate multiplication. The word out of indicates division. So like I said, that bar in your fraction is going to indicate division within that comparison. So now that we understand what a fraction is, let's take a look at this idea of being able to convert from mixed numbers to improper fractions and from improper fractions into mixed numbers. Now, we need to understand that this concept of a mixed number, what it indicates, when I have 6 and 7/8, be very careful and listen to those words carefully. 6 and 7/8. So what that tells me is I have 6 whole units and then a portion of another unit. Now, there's several ways to express this idea. One idea is to use, oftentimes we'll use circle graphs or pie pieces. So it's almost like talking about pizza or a pie or a cake. And this will indicate I have 6 whole pies. 1, 2, 3, 4, 5, 6 whole pies, and then a portion of that last pie. The last pie is not a whole one, it is a portion of it. And what this 7/8 tells me is I'm going to take that last pie, I'm going to cut it into 8 sections, but I'm only going to have 7 of those 8 sections. So in other words, I've got 1, 2, 3, 4, 5, 6, and 7. And so what that denominator does is it tells me the types of slices that I've got. That denominator says in order to create a whole pie, it would take 8 of these types of slice to create a whole pie. And you can see, sure enough, if I would put another one in there of that size, then sure enough, I would get a whole pie. Now that's one way to represent these fractions in circular pieces. Another way to represent them is a linear piece or something that looks kind of like this. In this case, what I have is a strip, but it says this length is what I'm going to call a whole. That length is a whole. So now I can say, well, what if I would take this whole and I would break it up into sections such that it would take 8 of these sections to create that whole. If it takes 8 of these sections to create that whole, then what I'm going to do is I'm going to call each one of these an eighth. So 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, 8/8. It takes 8 of these pieces to create that whole, so each of these is an eighth. So like we said here, if I have 6 and 7/8, that would indicate I have 6 of these whole strips, but then on that last strip, I don't have the full strip. I only have 7/8 of the strip. Another way of thinking about it is, say for instance, the idea of the fruit bowl or the classroom, saying that I've got sections of it, and in this section I've got full sections and 6 of them, but this section is not completely full. It only has 7/8 of that section full. Or another way of looking at it is, let's say that I want to give candy to my friends, and in each bag of candy I have 8 pieces of candy. So I have one whole bag of 8 pieces of candy to give to a friend, another whole bag of 8 pieces of candy to give to a friend, and I've got 6 whole bags, each of them with 8 pieces of candy to give out to my friends. But my last friend, unfortunately, I've run out of candy. I only have 7 pieces of candy to put in that bag. So I have 6 whole bags, but my last bag only has 7 out of those 8 pieces of candy. Again, there's that word out of. Out of is going to indicate division. So here again, this idea of a mixed number indicating 6 whole pieces, but only 7/8 of that last piece. Now, I'm going to just go with, in terms of doing this conversion thing, now that you understand the different ways of representing these whole numbers and these fractions, I'm just going to go with the circular idea to go with this concept of being able to convert. So here are my 6 whole pies. Here's that 7/8 of that last pie. To convert it to the improper fraction, impropers are typically what we call top-heavy fractions. You're used to fractions looking like this, where the top number, that numerator, is smaller than that bottom number, the denominator. You're used to those types of fractions. So whenever your numerator is bigger or larger than that denominator, top-heavy, that's what we call an improper fraction. But an improper fraction is still a fraction. It just looks kind of funny because it's top-heavy. So what we're going to do is convert this mixed number into this type of fraction, a basic one, but one that's a little bit top-heavy. In order to do that, what I'm going to do is I'm going to take a look at this and I'm going to say, well, you know what? That last pie piece over here was cut into eighth sections, or 8 sections. I didn't have all of them there, but it was cut into 8 sections. So what I'm going to do is take each of these whole pieces and cut them into the same types of sections. So I'm going to take each of these and cut them as well into eighths. Cut the first one into eighths. Cut the second one into eighths. The third one into eighths. The fourth one as well. The fifth one. And then finally the sixth one into eighths. And then what I'm going to do is I'm going to say, well, how many eighths do I now have? How many eighths? So because I'm looking at how many eighths, this denominator, the superhero of fractions, what I'm going to do is I'm going to keep that denominator of eighths, and I'm going to say, how many eighths do I now have? Well, let's take a look at the whole pies first. Now, I have 8 pieces here, another 8 pieces here, another 8, another 8, another 8. So I could say 8 plus 8 plus 8 plus 8 plus 8 plus 8. But what's faster than repeatedly adding? Absolutely. Multiplication is much faster than repeated addition. So what I'm going to do is instead of saying 8 plus 8 plus 8 plus 8 plus 8 plus 8, 6 times, I'm going to say, well, let's do 6 times 8, which is 48. So that tells me that I have 48 of these eighth pieces in the whole pies. So now I need to take this 48 eighth pieces and I need to add to it these 7 pieces. So 48 plus 7 gives me 55 of these eighth pieces. And that, my friends, is how you take a mixed number and you convert it to an improper fraction. Now you may be thinking, oh my gosh, I do not want to have to draw this out every single time, and I don't want to either. But what this does is this leads us into the rules or the process of converting this mixed number into this improper fraction. The process is this. You're going to multiply the denominator to the whole number, because that's exactly what we did right here to figure out how many eighths or how many of that denominator we've got in the whole pie section. So you'll multiply these two, but then notice after that, after we did that multiplication, we added in that numerator to get the total number of these sections that we've got. That is the process for converting a mixed number into an improper fraction. You multiply here, and then you add that numerator. And again, superhero of fractions is that denominator, so you keep that denominator. Now that we understand how to convert from a mixed number into an improper, let's work backwards, and let's convert an improper into a mixed number. Let's take a look at this idea of these 8/3. So 8/3 tells me, well, I've got these sections of thirds. Now remember, what this tells me, this section of thirds, it says it's going to take 3 of these types of sections to make a whole. Whether it be a whole in a linear piece, or whether it be this idea of portioning out candy, portioning out people in a room, or circular pie pieces. I'm going to go with the circular pie pieces because it's a little bit easier. Plus, I just really like the magnets that I've got here. Those are super awesome. But the idea is it takes 3 of these together to make one whole pie. But what this tells me is I have 8 of those types of pieces. So I have 3 here, plus I've got another one sitting here, and I've got another one sitting here, and I've got another one sitting here, that's 6, and I've got another one sitting here, that's 7, and I've got another one sitting here, that's 8. So what I'm going to do is I'm going to take these 8 pieces and I'm going to try to put them together to make whole pies. Clearly you saw I could do that here, but I could do it with these 3 pieces as well. So I'm going to take these 3 pieces and put them together to make a whole pie. Bear with me, I am not an artist at all, as you can see here. Those 3 pieces to create a whole pie, and I have 2 pieces left over. Now remember, up here I said this indicated 6 whole pies and 7/8 of another pie. So I have 2 whole pies and 2/3 of another one. And that gives me the mixed number for 8/3. Now again, if you're like me, I'm going, I don't want to draw this stuff out, and even though I really love my magnetic pieces, I don't want to have to carry them with me everywhere. So I need a shortcut. Where's the process coming from? Remember me telling you this bar meant division? And it does. So what I have to decide now is, am I going to divide up, in other words, 3 into 8, or am I going to divide down 8 into 3? Now, if you recall, we had another instructional video that talked about how to convert fractions into decimals. In that one, we said we always divide up. And we're still going to do that, still dividing up. It's just now when we divide up, when we were converting these into decimals, we said, well, 3 goes into 8 twice, and 2 times 3 is 6. And when we subtract them, we got that remainder of 2. Back when we were converting to decimals, we said, let's put a decimal point and string a bunch of zeros. We're not going to do that now. But what this division indicates is the same process of division, of dividing up. It tells us I now have 2 whole pies, like you see right here, and then 2/3 of another pie, 2/3. So once again, the process for converting an improper fraction into a mixed number is simply to divide up. And then take that denominator, put it over top of your divisor, remainder over divisor, to give you the fraction of what's left out of that last pie that's not going to be a whole pie, or last length, or last portion of a whole. Because that's what a fraction is. It is a part out of a whole, a portion of a whole. So now let's take our answers that we have here and let's review these concepts one more time. Remember, if I want to convert from a mixed number into an improper fraction, we said the process is multiply here, add here. That was the process that we discovered. So if we multiply here, 2 times 3 will give us 8. 2 times 3 gives, I'm getting ahead of myself. 2 times 3 gives us 6. 6 plus 2 gives us 8. Keep that superhero of fractions, that denominator, and so that gives us 8/3, which is exactly what we had. So we know that, number one, this is right, but number two, that gives us more practice in converting our mixed numbers into improper fractions. Now let's take a look at this improper fraction, and let's practice once again the idea of converting an improper into a mixed number. Once again, the bar means division. I'm going to divide up. So I'm going to take my 8 and I'm going to divide it into 55. 8 goes into 55 6 times, and 6 times 8 is 48. And when I subtract, I get a 7. And remember, I'm not turning this into a decimal, so I'm not going to put a decimal point and string a bunch of zeros. I'm going to say this indicates 6 whole pieces, whether it be length strips or parts out of whole or circular pie pieces. It's 6 whole pieces and then 7/8 of that last piece. I'm not getting a whole out of the last one. I have 7/8 of it. So 6 and 7/8, exactly like we have right here, 6 and 7/8. So hopefully that helps you to understand, number one, what a fraction is. Again, part out of whole, as you saw right here. Part out of whole, whether it be a part out of a whole in length or a part out of whole in circular pieces, as you see here, or whether it be a part out of a whole in terms of just representing anything at all. But that's what a fraction is, a comparison of two numbers by division, part out of whole. Key being out of, not just of, but out of. And now you can convert from mixed numbers to impropers and from impropers to mixed numbers. Multiply here, add here, keep that superhero of fractions, the denominator. Here, always divide up. Take your remainder, put it over your divisor to give you a fraction of what's left. I hope that helps. Have a great day.